Okay, in this video you guys are going to learn how to predict the direction of magnetic forces on current carrying wires. We're going to do so using the right hand rule, or we'll call it right hand rule number 2. So what you need to know to get started here is the hand is going to be open. It's not going to be curled like as in right hand rule number 1. And what we're going to do is we're going to point our thumb in the direction of the current, just like before. Our fingers are going to be in the direction of the B field, or the magnetic field. And then coming out of the palm of our hand is going to be the magnetic force. So whichever way your palm is facing, that's the direction of the magnetic force. So let's go ahead and take a look at this in various situations. Okay, in this example you're going to see a situation in which a wire is carrying a current directed to the left, and that wire is passing through a magnetic field that goes into the page. The reason the magnetic field is going into the page is because I have a north pole right here, and behind the north pole is a south pole. And field lines go from north to south, so that would be directed into this page or into the screen. And you can see the red wire is passing right through that magnetic field. So why don't you take a moment now and get your hand situated so that your thumb is aligned with the current and your fingers are aligned with the magnetic field. Okay, you think you got it? Now at this time there's going to be a hand coming out of nowhere, and that's how your hand should be aligned. You see the palm is facing downward, so when I turn the switch on, bam, there's a downward directed force. Okay, in this situation the magnet is in the same orientation, but if you notice right over here I took these leads and I switched them. Therefore we're getting a current that's going to the right instead of to the left. So same situation for the magnetic field, but currents flowing to the right. Go ahead and get your hand so that your thumb and your fingers align with the current and the field respectively. Again, a hand is going to come out of nowhere now, and you'll see it aligning itself so that the palm is now going to be up, so there should be a magnetic force up. Turn on the current and boom, force up on the wire. Okay, in this situation we have the current still flowing to the right, but the magnet is turned around now. If you notice, we've got the south pole right here with the north pole behind it, so as a result the field is going to be coming that way, which I would call out of the page. So go ahead and line up your thumb and your fingers now. Take a moment to do that, and let's see what the hand does. Yep, current to the right, fingers out of the page, forces down. Turn on the current and a downward deflection. There you go. Alright, example number 4 here, we switch the leads on the power supply again. So now we've got a current that's traveling to the left with the magnetic field coming out of the page. And you go ahead and take your hand and position it so that it lines up the current in the field. Your hand should look something like this. You see your palm is up on the screen. Turn on the current and we get a magnetic force up. Okay, something crazy different in this example. I've got the magnet which has been rotated 90 degrees. So now it's standing up on its end. And we have a north pole on the bottom and a south pole on top. Therefore the field is going to be directed upward like that, from north to south. At this time go ahead and place your thumb with the current, your fingers with the field. And as you notice the hand coming in here in just a minute, it should be so that your palm is facing inward. And so we turn on the switch here, and we're going to electric current, and there's a slight deflection inward. There you go. It's kind of hard to see, but there it was. Okay, in this situation we still have the magnetic field going up because of the north pole on bottom and south pole on top. We've got the current though going to the right. And so if you can go ahead and take your thumb and your fingers and get them aligned with the current in the field, that'd be great. And we're going to move the camera down a little bit so maybe we can see this wire's deflection. Notice the hand that's coming in here. It'll be aligned correctly, and the force is going to be outward. Turn on the current. Sure enough, we got an outward force on that wire. Okay, in this one you notice that the North Pole is now on top, and so we have a downward directed magnetic field. And as you take a look at the situation here, it looks like the current's still to the right. So we're going to have to go ahead and place your hand so that the field is down but the current's to the right. And that's kind of how it should look. Your force is going to be in. It's going to be an inward magnetic force. Turn the current on, and a little deflection in right. And in our final example, we have a current going to the left now with a downward magnetic field. So go ahead and place your hand in the right orientation. And if you take a look here, again, we'll move the camera down so hopefully you can see a good deflection. Hand comes out, thumb to the left, fingers down, the palm is out of the page. Let's turn on the current now, deflection out. So there you go. This is how we predict the direction of the magnetic force on a current carrying wire. Hope you enjoyed it.